to lesson 21. We're going to solve inequalities in this review. We're moving on from our just regular equation. Let's look at some inequalities, and here are two look fors. We're going to look to see that you can use the inverse operations to isolate each variable, and that you can solve the inequality with an accurate symbol at the end. So those are the two things we're going to look for. Again, these have to do with accuracy, and we've been working with inequalities since middle school. So this is a review. So before we jump into any practice problems and any modeling, I just want to review this one topic: multiplying by negative numbers with inequality. Why does something change? Why do we change the sign when we multiply by negative numbers? So I'm going to start with a really easy example. I'm going to look at 2 is less than 3. It's a very simple inequality. So what would happen if I were to multiply both expressions by -1? So if I did -1 times 2 and -1 times 3. Now I would have a new inequality. I would have -2 is less than -3. Is this a true statement? Well, let's make a number line. Here's 0, counting backwards, -1, -2, -3. We know that the larger symbol is always to the right. As we continue moving towards the right, the numbers grow larger. And looking at our numbers, here is -3, and here is -2. And so this statement would be incorrect. -3 is actually less than -2. So nope, this is just wrong. It is not a true statement. So what would make this true? It would be true if we were to flip the sign. So if we were to take that negative sign and just flip it around, -2 is larger than -3. Now that would be a true statement. So when we multiply both expressions by a negative, we have to flip the inequality symbol. Now, is that true if we're just multiplying by a positive? Well, let's see. Here's 2. 2 is less than 3, which we know is a true statement. If we were to multiply these by just a positive 1, there would be no change. It would still be 2 is less than 3, which is still true. So when we're multiplying by positive integers, the sign does not change. It only changes when we're multiplying by negative integers. Okay, so we're going to put that into our notes. Multiply by negative integers, and we are going to flip the sign. Flip the inequality symbol. Okay, this was the easy example I could think of to explain why it flips. And again, it's because that statement would not be true. And this is easy. We can see it with numbers, but when we have variables, we're not going to be able to know what that variable stands for. So we just have to remember to flip the sign. We have to catch that. Let's start with our first example. 12 minus 5x is greater than 72. All right, we're going to deal with our constant first. And since I have a positive 12, we're going to create a 0 pair by adding its opposite. We'll do that to both expressions. And now we have -5x is greater than 60. All right, let's isolate that variable. We're going to divide by -5. And a reminder, because we are dividing by -5 on both sides, we're going to have a change in the actual sign. So we have x. Now we're going to flip it over. X is less than -12. Because remember, we don't know what that x is, but we do know that when we multiply or divide by a negative number, the sign flips. So let's test this out. This means that any number that is less than -12 will work. So I'm going to draw it out first just so we can see it. Here's -12. And I want x to be all the numbers that are lower. So x would be on this side of the number line. So I'm going to draw a circle around 12. So I'm not including 12 in my solution set. And I want all the numbers less than 12. All right, so I just graphed my inequality. Let's try this and actually just choose a number. Let's choose -20 and let's see if it's true. So I'm going to take my original inequality and now I'm going to substitute -20. All right, let's distribute. -5 times -20 is +100. So 112 is greater than 72. So this is a true statement. So again, if we hadn't flipped that sign, if we hadn't, then we would have had x is greater than -12 and we would have chosen any number on this side of the number line, and those numbers would have created a false statement. So let's say you had tried, and again, this is going to be a non-example. If you forgot to flip, and so you would have x is greater than -12, then this is what would happen. You would have, I'm going to pick +20. 12 minus 5 times 20 is greater than 72. Okay. 12 minus 100 is greater than 72. 88, -88 is greater than 72. And that would be incorrect. -88 is not greater than 72. So again, we have to, anytime you multiply by a negative number or divide by a negative number, then you will flip the sign. Hit pause and jot this down into your notes. All right, we're going to try these last two. I'm going to go a little bit more quickly. Actually, I like writing in black. So a number divided by -2 plus 6 is greater than or equal to 10. I'm going to eliminate that constant first by creating a zero pair. So a number divided by -2 is greater or equal to 4. The inverse of dividing by -2 is multiplying by -2. So again, because this is happening, I'm multiplying by negatives on both sides, we are going to flip this sign. All right, so on this side, this would cancel. I would just be left with a number. And on the other side, 4 times -2 is -8. So here's our solution. I'll graph it really quickly. Here's -8, and I want n to be all the numbers that are less than. So here's all the numbers on this side. I'm going to fill in my circle because it's less than or equal to -8, and I want all the values less than. We'll do a check. We'll try -10. So n divided by -2 plus 6 is greater than or equal to 10. So -10 divided by -2 plus 6. This would be 5 plus 6 is greater than or equal to 10. And that is true. 11 is greater than or equal to 10. So we have a true statement. Let's try the next one. 25 is less than 9w minus 2. Right now it's feeling like second nature because we've done so many of these, so we know where the zero pair is. 27 is less than 9w, and we're dividing both sides by 9. 3 is less than w. Notice because I didn't multiply or divide by a negative, I can stay with just that number. I don't have to flip any signs. All right, let's graph it. Here's 3, and w is greater, so it's going to be on the right side. Because it's not equal to, we're going to leave the circle open. And we want all the numbers that are greater than 3. I'm going to choose an easy number to work with. I'm going to just choose 10 for my check. Since that's a number greater than 3. 25 is less than 9 times 10, minus 2. Distribute 90 minus 2. 25 is less than 88, and that is a true statement.